Hello students, welcome back to Easy BTech channel and you are listening to the course of Signals and Systems. So we are in the first chapter and we are in the topic of classification of signals. We will continue this topic and in this video we will be looking into the next classification, which is periodic and aperiodic signals for continuous time case. Okay, so we will go into the topic directly. Any continuous time signal x of t is said to be periodic if it satisfies the given condition. So what is that? X of t plus capital T should be equal to x of t. Okay, the least positive real value of capital T which satisfies this condition, we call it as what? Fundamental period of the signal. Okay, and note that fundamental period is always a positive real number. Why? Because the period of a signal is nothing but reciprocal of frequency. And what is frequency? It is a number of repetitions in 1 second, and definitely the frequency cannot be negative and hence period also cannot be negative. Okay, so note that capital T equal to 0 will satisfy this condition, but we don't take that as the fundamental period. Okay, so what is the rule? Fundamental a signal is said to be periodic if it satisfies this given condition, and the fundamental period is always a positive real number. But what is the fundamental period? It is the least positive value of capital T for which this given condition is satisfied. Okay, and what is important thing that we should see? We should note that a periodic signal, if the fundamental period is capital T, then it is also periodic with period for integer multiples of capital T. So that means the given signal x of t, if it is periodic with period capital T, then it is also periodic with period 2t, 3t, 4t, 5t, and so on for integer multiples of n. So in general, we can say that what is that? X of t plus for some integer m times capital T is also x of t. Okay, capital T is fundamental period, but the signal x of t is periodic with period which is integer multiples of capital T. Okay, so for example, we can say that x of t plus 2t is also x of t. Okay, so note that this m should always be an integer. It cannot be a real number. Okay, so in that way we can take any integer multiple of capital T and still that turns out to be the period of the signal. Note that it is not fundamental period. Okay, fundamental period is capital T, but any integer multiples of capital T still can be the period of the signal. So for example, we can say that x of t plus 10 times capital T is also x of t, and in that way we can have any number of examples. Okay, right, so we will take two simple examples and we will try to find out the period of the signal. So first example is x1 of t is given to be 2 cos t. Note that multiplication of the signal with a constant value does not change the period of the signal. So for example, the period of cos t and period of 2 cos t would be the same, but we will try to find out what is that period. Okay, so what is the requirement for the signal to be periodic? So we are talking about first signal. Okay, so what is the requirement? X1 of t plus capital T should be equal to x1 of t. So that implies what? 2 cos of t plus capital T should be equal to cos t. So when is this possible here? We know that cos theta is periodic with period 2 pi, and hence what should be the value for capital T? That should be equal to capital 2 pi. So this implies capital T should be equal to 2 pi. So just for understanding, we can write down that cos of theta plus 2 pi is equal to cos theta. So we are using this rule. Instead of theta we have t, and instead of t we have 2 pi, and hence what do we say? We say that 2 cos t, the signal 2 cos t is periodic with period 2 pi. Okay, and now let us look at the second signal. So x2 of t plus capital T should be equal to how much? x2 of t. If this condition is satisfied for some value of capital T, then we say that particular capital T is the fundamental period of the signal. Okay, note that the scaling factor, the amplitude of the signal can be complex. Okay, still it is a constant, complex constant. So that is acceptable. Okay, so what is x2 of t plus t? So that would be 1 plus j times e power j times 3 pi times t plus capital T. Okay, and that should be equal to e power j, that should be equal to 1 plus j times e power j 3 pi t. So we will take the first term on the left hand side. So we'll write 1 plus j times e power j 3 pi t multiplied with e power j 3 pi capital T. Okay, and this fellow should be equal to 1 plus j times e power j 3 pi t. So when is this possible? Only if this fellow turns out to be 1. So when will that fellow be 1 here? We want the encircled term to be equal to 1. So when is that possible? When is that possible? If you replace this capital T with 2 by 3, correct? So what happens? So this implies, what do we say? This is possible only if capital T equal to 2 by 3. Why? Why? Because if you replace capital T with 2 by 3, what will happen? 3 and 3 will get cancelled out. We will get e power j 2 pi. E power j 2 pi is nothing but 1, and hence the circled term would be equal to 1 provided capital T equal to 2 by 3, and hence what do we say? The period of the second signal x2 of t is 2 by 3. In that way we can find out the period of the signal. So I forgot to mention, what is that? If we cannot find any value of capital T for which this condition is not satisfied, then we say that signal to be an aperiodic signal. So if you cannot find any value of capital T for which this condition is satisfied, then we say that particular signal x of t to be an aperiodic signal. Okay, right. Now we have seen the periodicity of a single signal. Now let us consider what happens if you take addition or linear combination of two periodic signals. Okay, so what do you mean by that? I have a signal x1 of t which is periodic with period t1, and I have a second signal x2 of t which is periodic with period t2. Now I am interested in finding the period of this new signal ax1 of t plus bx2 of t. Okay, first let us try to find out what is the condition for this new signal to be periodic. Okay, so let me call that new signal to be x3 of t, which is equal to a times x1 of t plus b times x2 of t. Okay, and we want this signal to be periodic, and let that period be capital T. So this implies, I'll write down that, let capital T be period. Okay, so be period of x3 of t. Let capital T be the period of x3 of t. So what should happen? We need x3 of t plus capital T to be equal to x3 of t. Okay, so what does that mean? A times x1 of t plus t1 plus b times x2 of t plus t, sorry, a times x1 of t plus t plus b times x2 of t plus t should be equal to a times x1 of t plus b times x2 of t. But in the previous slide, what is that we have seen? We have seen that if a signal is periodic with period capital T, that fellow is also periodic with period for integer multiples of capital T. So let us come back to the question. So what is that? Here we have to satisfy the condition that ax1 of t plus capital T plus b times x2 of t plus capital T should be equal to a times x1 of t plus b times x2 of t. So for this to happen, what is the requirement? This capital T for first case should be equal to what? So that should be some integer multiple of t1. Correct. So you want x1 of t here. If you want x1 of t here, this T should be integer multiple of capital T1, which is a period of our first signal. Similarly, what should happen to the second signal? We want x2 of t back. So definitely if you want x2 of t back, this capital T should be what? Integer multiple of t2. So that implies capital T should be equal to integer multiple of t2. Okay, so integer multiple of t2. So from this, what is that you observe? Note that the integers can be different, and hence I took m and n respectively. So because left hand side is equal, which is equal to capital T, we can see that m times t1 should be equal to n times t2, and this implies what is that? T1 by T2 should be equal to n by m. Okay, so T1 by T2 should be equal to n by m. But what are m and n here? They are integers, right? So m and n are integers. Okay, so m and n are integers. So if you take ratio of integers, what do I get? We get a rational number. So this m by n should be a rational number, and the representation is q. Okay, for integers we use z, for real numbers we use r, and so on. For rational numbers we use q. So what is the requirement for the linear combination of the signals x1 of t and x2 of t to be periodic? What is the requirement? The ratio of the periods should be rational number. Okay, and what is the period? That period is given by either mt1 or nt2. Okay, and you can prove that capital T is nothing but LCM of T1 and T2, and we are not going to see that the proof. Okay, so the period turns out to be LCM of T1 and T2. So we will be relying mostly on this condition. We will not use LCM of T1 and T2. Okay, we can use that, but yeah, so for examples let me not use it. Okay, so now question is, we'll take an example, and the question is what? We have to find the period of this new signal 2 cos 2t plus 2j times e power j 3t. So this is looking like what? A times x1 of t, correct, plus b times x2 of t. So what is a? It is 2. What is x1 of t? It is cos 2t. What is b? It is 2j. And what is x2 of t? It is e power j 3t. So definitely what is that we have to find out? We have to find out first what is the period of the first signal. So we can easily see that period of first signal would be equal to how much here? That will be equal to pi. Okay, so you can prove that the period of the first signal is pi, and similarly the period of second signal would be equal to 2 pi by 3. Okay, so period of second signal would be equal to 2 pi by 3. So that's easy to prove. Okay, now what is that? What is that we have to do? We have to check whether the ratio T1 by T2 is a rational number or not. So what is T1? That is pi, and what is T2? That is 2 pi by 3. So that turns out to be how much? So this pi will get cancelled, so that will be equal to 3 by 2. And because that fellow is a rational number, what happens? The given signal x of t is a periodic signal. Okay, so this implies x of t is periodic because the ratio is a rational number. The given signal x of t is periodic. Okay, but what is the period? So in the previous slide we have seen that period is nothing but how much? M times t1 or n times t2. So that is what we have here. So period t, so if you cross multiply, what happens here? You get capital T to be equal to either 2t1 or that is equal to 3t2. So this turns out to be how much? 2 times t1 is how much? Pi. Or you can say that that is 3 times 2 pi by 3, which is equal to 2 pi. Both will give you the same answer. Or if you are not okay with it, you can take LCM. So that would be LCM of T1 and T2, which is equal to pi and 2 pi by 3. So if you want to use LCM, you can do that. So capital T would be equal to LCM of pi and 2 pi by 3, and you can prove that that would be equal to 2 pi. Okay, so period of the signal, whichever is simpler, you can use it. In that way you can find the period of the linear combination of periodic signals. Okay, right. If what happens if t1 by t2 is not rational number, then that the given signal it turns out to be not a periodic signal. Okay, so whatever we have seen till now, let us extend to multiple number of signals. So what do I mean by that? So let's assume that I have x1 of t with period t1, I have x2 of t with period t2, and so on up to I have xm of t with period tm. Now what is that I want to find, I want to check whether the linear combination of these signals, which is given by summation k equal to 1 to m ak xk of t, is periodic or not. Okay, first we will try to find the condition and then we will find out the period of the signal. So we can extend the result what we have got previously to most number of signals. So what do I mean by that? So this new signal whatever we have got, let us call that to be x of t. Okay, so what should be the condition? If you have only two signals, we just check t1 by t2, but because we have a lot of signals here, we have to take all the combination, all the ratios of all the periods. Okay, then that ratio should always be a rational number. Okay, so x of t is periodic. Okay, so x of t is periodic if and only if what, all the ratios, what are they? T1 by T2, okay, and T1 by T3, and so on up to T1 by Tm. Okay, and similarly we need T2 by T3 and so on up to T2 by Tm. Okay, so T2 by Tm, and again like that we have to finally check Tm minus 1 by Tm are all if and only if all these ratios are rational. Okay, so all these ratios should be rational numbers. So then what do we say? The given signal is periodic. Okay, the given signal is periodic. If the condition is if all these ratios are rational, then the period is given by what? Capital T is equal to LCM of T1 to Tm. Okay, so capital T is given by LCM of T1 to Tm. So in that way we can find out the in that way we can check whether the linear combination of many signals is periodic or not, and if all the ratios turns out to be rational, then what do we say? The given signal is periodic and the period of that linear combination is given by LCM of T1 to Tm. Okay, so we will take again one example. Here we took x of t to be root 2 sine pi t plus 3 cos 3 pi t by 2 minus sine 2 pi t. So we want to check whether this signal is periodic or not, and if it is periodic, what is the period? So definitely this is looking like a x1 of t plus b x2 of t plus c x3 of t. So we have to check the fundamental periods of each signal. So for first signal, what is the period? We can easily prove that that is equal to 2, and for second signal we can easily prove that capital T equal to 4 by 3, and third signal we can prove that T3 equal to 1. Okay, so T1 is 2, T2 is 4 by 3, and T2 is 1. And if you pick up the ratios, so what is that? T1 by T2, that turns out to be 2 by 4 by 3. Correct, so 2 by 4 by 3, so that turns out to be how much here? So 3 by 2, so that is a rational number, and then we check out T1 by T3, which is equal to 2 by 1, which is again a rational number, and then finally we check T2 by T3, which is equal to 4 by 3 by 1, which is again a rational number. And hence what do we say? Because all the ratios are rational numbers, the given signal is what? It's a periodic signal. But what is a period? So period capital T is given by, okay, we'll write down that this implies x of t is periodic. This implies x of t is periodic. Okay, now let us try to find out the period of the signal. So because it is periodic, we have to find out the period of the signal, and that is given by what? Capital T equal to LCM of T1. What is that? 2, T2 which is 4 by 3, and T3 which is 1. So what how do you find LCM? We will try to multiply and divide by 3. Okay, so I'll take 1 by 3 out, and LCM operation is linear, so you will send 3 inside, so that will be equal to 6, 4 and 3. So LCM of 6, 4 and 3 would be how much? So that would be 1 by 3 times. So let me do that. 6, 4 and 3, right? So I'll take 2, that would be 3, that should be 2 and that should be 3. So what should be the again LCM? I'll do with 3. This is 1, 2 and 1. So what would be the LCM here? That is 3 times 2, which is 6. 6 times 2, which is 12. So that would be equal to 1 by 3 times 12, which is equal to 4. So that turns out to be the fundamental period of the given signal. So what is that? Capital T would be equal to 4. Okay, right. So in that way, we can first, what is the first thing? We should check whether the signal is periodic or not, and then only we can find the period of the signal using LCM. Okay, so this second signal, which is given by x of t equal to 2 sine t minus 2 minus j cos t by 2 plus 1 plus 3j e power minus 2jt. So this signal, I will leave it as homework. So what is that we have to do? We have to find t1. So note that 2 minus j is a constant. It is a complex constant. That's okay. So no problem with that. So we have to find t2. We have to find t3 and then check t1 by t2 is how much? Okay, so t1 by t2 you have to find out, t1 by t3 you have to find out, and then you have to find out t2 by t3. Okay, if all these are rational numbers, we can find the capital T to be how much? LCM of t1 and t1, t2 and t3. Okay, so that is the way how you find the period of the signal. But let us try to evaluate the period of this signal. So for this is again looking like linear combination of 3 periodic signals. So what is T1? You can prove that that is equal to 2. What is T2? You can prove that that is equal to 1. And what is T3? You can prove that that is equal to 2 pi. Okay, so you can prove that period of last signal, which is e power jt, is 2 pi. So what happens then for the ratios here? So t1 by t2 is 2 by 1. That's a rational number, not a problem. T1 by T3, that turns out to be how much? 2 by 2 pi, which is equal to 1 by pi. So definitely pi is not a rational number. Similarly, you can prove that, you can see that T2 by T3 is again 1 by 2 pi, which is not a rational number. So this implies what? Because even if any one of the ratio is irrational, then we say that the whole signal is an aperiodic signal. So and hence what do we say? Because we have got the ratios to be irrational, what do we say? We say that the given signal x of t is not periodic. Okay, so even though individually they are periodic, but because the ratios are turning out to be irrational numbers, the ratio of periods are turning out to be irrational numbers, then we say that the given signal x of t is not a periodic signals. In literature, we call these kind of signals as what? Almost periodic signals. Okay, so this example, the last one, I mean this signal is an example of what? Almost periodic signals. Okay, that is just for uh, understanding. Okay, we don't see almost periodic signals here, so that is the work of mathematicians. Okay, so we call this kind of signals as what? Almost periodic signals. Okay, right. So with that, I will conclude this lecture, and we will try to understand the periodicity of continuous time signals in the next lecture. Thank you.